And live. Okay. Okay. So hi, everyone. Welcome to the first webinar of 2021 in English. We're very happy to have you all here. This is a webinar that I think all of us, well, many of us at least, have been looking forward to. A very modern day topic, the use of drones in cetacean research. We're very happy to have AIMM Portugal with us today. All the webinars that we are doing this year are free so the people doing it are doing it for free. So a huge thanks to AIMM Portugal for providing this content for all of us to enjoy for absolutely no charge. These webinars came as an idea in a not so happy times with the pandemic. People started using Zoom and other softwares to communicate, and for us it was an opportunity to have even more content in our festival that you usually couldn't have. And it also works as sort of a teaser for the people that are unsure of what to expect in our festival. So now you'll get a glimpse of what to expect there. AIMM Portugal will be with us in Sagres from the birdwatching festival will happen in Sagres from the 1st to the 5th of October, for those who don't know. And they will be with us there. They will do 2 activities, one discussing the megafauna of Portugal and the seas, and another activity to discuss observation techniques for cetaceans. So both topics that are, I think, also very interesting. So if you enjoy what you see today, come to Sagres and join us in the activities there. The Birdwatching Festival is a free event. I can't stress this enough, with more than 200 activities. And some of the activities are paid, the ones that have significant costs for the partners, but for the most part, they are free, which is something that we're very proud of. So without further delay, I'm gonna pass this on to the people that you've come to listen. André from AIMM Portugal. He's an operations manager and also researcher. So André, take it away, please.
Okay, thank you very much, André. Thank you for your introduction. So hi, everyone, and welcome. My name is André. I am a marine biologist and a researcher at AIMM. And I'm here today to talk about the use of drones in cetacean research. We're going to be focused mostly in the work that we have been making here in Portugal. So before we start talking about drones, I would like to do a very brief introduction to you about AIMM. So I'm born from an initiative of young marine biologists that decided to create this no-profit organization back in 2010. Our vision was to be a reference for research, conservation, and education regarding the marine environment, but also provide scientific data to support conservation monitoring programs and, of course, helping in the marine policies. We also have a very strong area of our work is to support the responsible activities, ecotourism activities that we have around our research area. Speaking on it, our research area is the Algarve region, okay, is where we do most of our field work, and is also where we have our field station here in Albufeira, right in the center of Algarve. In the past, we have, for example, we have a project in Cape Verde where we worked for 3 years, and this is also our intentions to work in another place of the Atlantic Ocean or even in the world. Now, our main research areas are dynamic population of megafauna, ecology of megafauna, behavior and social organization of cetaceans, and touristic support for these touristic activities, namely the cetacean observation or whale watching that we have here in our area. These are 4 different areas of our work, between others. For example, so we are in coordination of this whale watching network that we have here in Algarve. in the specific time of the year, so from May to November, more or less, we conduct our scientific surveys in the daily base here in Algarve. We also participate in the few oceanic expeditions, for example, Marvish a few years ago, also the project Sirena organized per NATO and others. And we also have a strong environmental education actions that we promote every year in these webinars, in talks we give to schools or even to, well, to open public. But this is also a strong component of our work here. Now, I would like you to leave with this small video about, well, we'll show you a few different species of animals of biodiversity that we have around Portugal. And, well, okay, I hope you enjoyed this video. This is just a small example of the huge biodiversity that we have around Portugal, mainland of Portugal. And all this footage were made or captured by us here in Algarve in 2016 and 2017 season. So of course we don't see this everything in one day, but it's possible even to see more species that I not retract in this video. So yeah, we really have a huge biodiversity around here that it needs to be protected and studied, of course. Okay, moving on now for the topic, the subject that bring you all here, and we're going to talk now about the drones and the use as a research tool for whale research or marine research. So drones are already used in the world in several sectors of our economy, as well in the scientific world. And these are the 4 topics that we're going to talk during this presentation. Okay, in 2016, when we start a new PhD program, we want to use a drone to collect footage or image to study behaviors and social organization in common dolphins. And in that moment, we found ourselves with a problem or with a question: if or how will be the impact of our drone in the dolphins that we want to study. And since we want to study the natural behaviors of the dolphins, it is possible to do with a drone, or the drone will make too much impact on the animals that will completely change these behaviors. So this was the first study. Our first work with the drone was exactly to understand the impacts that the drone can have in small cetaceans. And then we move on and we start, well, our studies in ecology and behavior. And I can tell you that there is an enormous potential of use of the drone footage from for these studies, because you will see, I will show you a few movies later on, and you will see that the perspective that we have from the drone, the ability to see the group of dolphins from the top, it's quite amazing. It's quite new for us that are used to see dolphins from the surface level, more or less. So of course that allowed us to put us in a very nice point of observation, the camera of our drone, to do this ecology and behavior studies. And then there are more things that we can do with drones, for example, the photogrammetry, where we can, through this, we can calculate the exact size of an animal. This methodology can be performed from a drone and is extremely cheap and efficient compared to the classic method that was made by a small airplane or a helicopter. And the last methodology that we're going to explore and talk a little bit about is the collection of blows. And this is extremely interesting because it allowed us really nice studies, or we collect really good samplings for genetics, for microbiomes, but also for hormones. Okay. And is also our intention to understand if the use of the blows, for example, from whales, it could replace the needs of making biopsies of the animals. Of course, collecting a blow with a drone is a completely almost no invasive technique for a whale, and collecting a small biopsy, even for the smaller it is, the animal will feel it. So we also have this idea in mind to understand if it's possible to change these methodologies for one that is much more or much less invasive. Okay, so now let's talk about the assessing behavior of dolphins with drones. So this was our first project with drones in Portugal, and since I explained it before, we want to understand what kind of potential impacts the drone can have in the group of dolphins. We did this study with common dolphins and bottlenose dolphins here in the south coast of Portugal, in the Algarve region. We started this in 2016 and 17, so we collect data in these 2 years, and the study is already done and published, and was published this year in January 2021, and is an open access. So if any of you wanna read or wanna know more about it, please go ahead and have a look. But very briefly, to explain you this experience, what we did. So we decided to fly our drone at different heights. You can see here 50 meters, 45 meters, 40 meters, and we come down 5 meters each 30 seconds in order to try to observe or register any response from the dolphins to the drones, and try to check what could be the height that they have this response. Okay, so our results show us that there was no significant change in traveling speed or diving behavior for these two species. And I want to make a note here. So this arrow here represents direction on change. This one represents swimming speed, and this one diving behavior. Okay, so in none for swimming speed and diving, we found significant change, but this was record for common dolphins at 5 meters. Okay, and was the unique significant change that we found in our statistic for the common dolphin at 5 meters. But 5 meters is already quite a low height to be with the drone. Sometimes we are not even able to get all the group, depends on the group size, of course, at this height. Nevertheless, I'm not saying that it's correct that we can fly drones until 5 minutes. Far away from that. This was what our show presents, but this is also we need to take in considering the behaviors and the fact that this population that we work here is already dealing with a lot of anthropogenic pressure. So be careful, because if we run this study in an area, a more pristine area without, well, human activities, the animals might react in another way. Okay, and now moving on for ecological and behavior studies with cetaceans. So after we finish our impact study, or a little bit simultaneous to the impact study, we start collecting this footage, the footage I talked with you in the beginning for this project of social organization in common dolphins that have a special focus in maternal strategies. So in this video that we're going to see now is exactly that, is a focal follow with common dolphins. So we follow the group of common dolphins for as long as we can. And then this data is to be analyzed on the computer later on. And now this is quite a long video. We will not see them all, but I will use, well, a few moments that I think are important for you to understand a little bit about this methodology and also the problems that we sometimes have with this. So the drone just take off from the boat. This is our research boat Kirts. And now you will see that as soon as I raise the camera, we have all this vast ocean in front of me. And this is my first problem as a drone pilot, is to find the dolphins in this ocean. Because as you can see, there are no reference. And I have people on the boat tell me, yes, go ahead. They are straight ahead. Keep going. They are there. But then I go straight ahead, but I'm not going on the right direction. So, well, you really need to build up your technique and use, for example, here I found now what I'm going to do is I'm going to take the drone to the left to find the boat and use the boat as a reference to understand the direction I need to go. You see the boat is coming on screen now, and I understand, okay, the dolphins are somewhere here on the front. I can already see them here. But the problem is on the ocean, on the boat, and the screen that I have at this time was really small with very bad quality of image. Although I was seeing this live stream on the boat, the quality was terrible. Okay, and now we start our focal follow with this group of common dolphins. This is a small group. I didn't count them yet, but I think they are around, let me see, 15 animals maybe. Yeah. And for now, from this moment, or like a few seconds early, we can start using this data for the social organization project. And what we do is we need videos with a minimum of 4 minutes, okay? Although our videos were a little bit bigger, but 4 minutes was the minimum we need to have to use it. And each 30 seconds, we record a few variables that I'm gonna talk with you about it very soon. But before that, I would like you to look at, this is a good moment, and try to see, because there is at least one mother-calf pair here in this group. Try to see where we see a very small dolphin swimming almost under the mother tail, the peduncle, the back of the animal, or sometimes they are really close on the side, in one of the sides. And if you look carefully, you will see that they are here. Okay, so this is the mother-calf pair that I think we have in this group. We have other dolphins swimming together, but the difference on sizes doesn't exist. So I'll say they are 2 adults or 2 juveniles, but this one is the mother calf. And sometimes it's really difficult to see because the calf tends to go under the mother and have this mother calf position. So this was more or less the target of our study. So we want to understand about the maternal strategies that common dolphins have. So we were, some of the data we were taking was really focused in this matter. And for example, the variables that we assess and that I mentioned before, and keep in mind that we do this every 30 seconds. Okay, it's a quite exhaustive work to do, but the fact that we can do it in the computer and we can stop the video, we can go back and forward and choose the right moments, it kind of make it easier as well, because we did this study from the boat live, collecting this data but with our eyes, and was much more exhaustive because for 1 hour we could not stop to go to the bathroom, to do nothing. We were just, well, collecting this data. But getting back to the variables that we assessed, so they were of course related with social organization. So for example, we have the formation of the group, so how the animals are, what formation they are doing, the cohesion, so how much space we have between dolphins, number of animals, group spread, so how many meters from one side to the other, group behavior, and then other individual behaviors, for example, social sexual, belly ups, or nurturing. Of course, if because we are focused on the maternal strategy, nurturing, it was a behavior that we were looking for. But we also look for the number of calves, the distance between the calf and the mother and the nearest neighbor, okay, was also some information that we want to know, and the mother calf position in the group, okay, that right now it looks more or less in the center, but sometimes we found the mother calves leading, or sometimes we found them in one side. It kind of depends a little bit what the group is doing and what is the mood of the mothers. Okay, so this, I will say this is a very good example of a focal follow, and the easy one, okay, because we have a very small number of animals, a very small group, just one calf. So of course there was work to be done with this video, but it was not a lot. I will show you another video that you will see that this can become quite complicated. And I also mentioned that we measure distance, okay, and it's a very easy way to do it. Is we know that common dolphin adults, the length of a common dolphin is more or less 2.2 meters, and then we use that as a scale, and then we just measure the distance with that. Of course, there is a small error associated to that, but we always try to choose one animal in the center of the view to reduce the fisheye effect that we have in this camera. And this was the way that we measure this distance. Well, we can see these animals, they are really calm. I will say they are in the slow traveling. We see sometimes animals socializing a little bit. For example, those two, we see a belly up. Every time we see a belly up, this is a social behavior between these two dolphins. For example, there again. Well, but definitely this was an easy group for our, well, for me as a pilot, because you see I keep the animals on frame more or less okay. I just cut it 2 animals now. I don't know why. Come on, back on frame. Okay, they are here. As a pilot, of course, there are a couple of challenging when we fly a drone on the ocean. The first of them that in this video is quite good is the sun glare. But if you look here on the lower part of the image, sometimes we have a very bright glare here. This is because, well, the drone is on the air, the camera is not vertical, but almost vertical. And of course, the sun will reflect at the surface of the ocean, especially in these calm waters that like we have today. So there is always, I always need to turn the drone in the position and up, bring the camera up a little bit to a certain angle and the position that I'm not getting this sun glare. But sometimes the dolphin change direction, they go in the sun glare direction, and then I need to fly around the group to position myself in another, well, angle or relative position with the dolphins and the sun. So that I will say is my one of my biggest challenge. Of course, in the ocean, as you see in the beginning, there are no main, or there are almost no reference. So also finding the animals sometimes could be challenging. You see in this group, I took perhaps 1.5 minutes or 2. But if you think that at this time, my drone have 30 minutes flight time, 2 minutes is a lot. So we really need to optimize this first moment and found the dolphins quickly, put the drone there, start record, because this was a, well, 5 years, 6 years ago, when the drone we have was almost a prehistoric drone that flies just for 13 minutes, maybe 14, but I will be really, really like on the limit. Also, and this is also a good point here, in the ocean, we don't have emergency landing place. So I always need to bring the drone to the boat. That is what I'm doing now, and has been collecting by my colleague Joana Castro. Okay, and we land safe, and well, we finished this. I think this was an 8 minutes video or around that, because the batteries in this moment, they really were a big limitation for us. Okay, moving on. So in this behavioral study, we collect a lot of videos, but we analyzed just 49 of these videos and in the total of 17 hours, okay? And this took more or less 3 months of 2 persons working time. Okay, so 2 persons working full time on this. It took them more or less 3 months to analyze. So, well, it was kind of a hard work to be done, but it's done. And now we are, well, currently doing our statistic analysis and writing the scientific paper that should be coming out very soon, we hope. Okay, now the next one, this is a great example how things can get hard, if not impossible. I will not say to make, well, the footage, I can fly that around on the top of this group, but now have a look and try to see how many, well, you will not be able to count them all, but give me a rough idea how many animals you think we have here. I didn't count them. Well, to be completely honest, I didn't. When I was preparing this presentation, I make a rough estimation of a number, but I would like to hear from you. You can maybe type on the chat how many dolphins you think we have here. These are common dolphins, like in the previous video. And what I want to note or call your attention now is to this area of the group. If you see here, almost all these dolphins are mother calves. Look, mother calf, mother calf, mother calf, and so on, so on, so on. If you look careful, under the big animal, we have a small one. Instead of 1 fin, we have 2 tails swimming there. And well, here, these are not mother calves anymore, but this is a mother calf. And these guys here have a few mother calves. And now note, I raised the drone to try to get all the dolphins in frame. But when I do this, and at this height, I think I should be around 30 something meters, we lose the ability to identify our mother calf. So, well, some can see, but most of them, they are already just in one body, one big animal. So this is our challenging. So if I want to have all the group in frame, I really need to, well, fly the drone very high. But then I lose my ability or the ability for us to check the details and to really be able to get the data we need. Okay, I see a few numbers: 120, 100, 150, 150 to 200. Okay, I think you are quite good. Oh no, now I lose my video. Okay, sorry. I think you are all quite good with the numbers. My rough estimation will be around 150 animals. Yes, this was quite a nice group, quite a nice shot for my drone. But we didn't analyze this video. Well, because of the reasons I present to you, it will be impossible to take good data out of it when we have such a big group like this. It's a shame because we have a lot of calves, a lot of mother calves here, but it was just too many. So we also, well, of course, we also have limitations. Drones are amazing, they do amazing things, but we have limitations. The video is back. But I think I'm going to move on because this, well, it's more of the same. Now it's a nice moment. We have these animals here that are going to start socializing a little bit and going to start messing up around the other dolphins that are very calm. And these 3 animals, they're going to kind of wake up the group. And again, this is another, you see the perspective where we are and what we can see from here is quite amazing. From the boat, well, from the boat, we will be in one side of the group or on the other side of the group, and we will never be able to see this well, movements at the surface, but not just the surface, but also the behaviors that is happening under the surface. For example, now we can follow these animals. They are swimming maybe 1-2 meters underwater, and we can see clearly what they are doing. They are socializing. Okay. Let's keep going. The group in the frame, but was just too much. Okay, but now I'm going to show you another example of a great use that we can give to a drone. This was not really for well, social organization study, but was to check a situation that we found on the ocean. Let me start the video. So in this situation, we found a minke whale that was in really, really bad conditions. But, well, I will let Dan, that is the speaker on the video, explain you everything.
Today we were lucky to find 3 minke whales around our research area in the south of Algarve. Minke whales are the most frequently sighted species of baleen whale around the south coast of Portugal, but it is rare for us to find 3 in one day. Unfortunately, one of these animals appeared to be in poor physical health. Even from a distance, we could see that the animal was swimming extremely slowly and with a very atypical surface behavior. It was also possible to observe that the animal had a very poor body condition. It was very skinny with a clear peanut head, prominent shoulder blades and vertebrae visible beneath the skin. Although the animal was moving very slowly, we didn't feel very comfortable with our research vessel, Kirts, getting too close. So we decided to not force an approach and instead use our drone to have a better view of the animal. At this point we were concerned that the animal could be entangled in something. But thanks to our drone, we could safely observe the animal from a close distance and could confirm that the animal was not entangled in any fishing gear. Nor did it show any signs of previous interactions with it. Thankfully, this was the first time the AIMM team has spotted an animal in this physical condition, and it was very hard to witness this magnificent animal struggling just to swim and breathe. But it was an important reminder for everyone on board Kirts how fragile the ecosystem is in which these wonderful creatures live, and how important it is for us to help preserve it.
In this particular moment, we use our drone to check what's going on with this animal. So I didn't want to get my boat close because I know the boat will stress out the animal, and the animal at the distance was already show a sign that it was not doing well or great. So we were there, we were observing other minke whale in another direction, and then once we have a time, I put the drone on the air and we went there to check this whale. So this was well, another very useful thing that we did with our drone in this situation. But now let's move on to the next one. For example, here, this is a very short video of harbor porpoise. Harbor porpoise are one of the most shy and difficult species of cetaceans that we have in Portugal, in the mainland of Portugal. And let me start the video. This was a chance that I have this already in this field season. We found a group of porpoise. We can never get close to the boat. The boat always stay, well, 300, 400 meters if you don't want to scare them away. And then they stay kind of remain at the surface. So I just prepare the drone and put it on the air, and I get this amazing footage of them. And these are really new things for us. We never see, for example, what is happening now, these two animals like interacting like this, because from the boat we just see, well, the fins when they come to the surface, and that's it. We have no idea what they are doing besides that. So this is it was a really cool footage that I get, and rare. I have like 2 flights with harbor porpoise with success, because many times I put the drone on the air to record these animals, but I never found them on. They just disappear. They are also quite small. They are the smallest of the cetacean species that we have here, around 1.5 meters. And they are also the most vulnerable of extinction the conservation status is actually vulnerable around the mainland of Portugal. So this was, yeah, a really, really nice image that we got, and well, give me some ideas, maybe try to start a project to study these animals through drones, since it's so difficult to get close to them. And for example, to take a picture for photo ID with these animals is almost impossible here in Portugal. In other places in the world, they behave a little bit different. And for example, from land, you can see them and you can, well, they don't really move away or are scared when you are in land. But here in Portugal, well, we don't find them very close to the shore usually. Okay, and the next one, this next video is from, well, completely different animal. I think by this frame, you can already see that this is a hammerhead shark. But again, I just want to, well, highlight that was because of the footage we got in the video that we were able to make a positive ID on the species. Okay, we know it was a hammerhead shark because we can see the shape of the head, but then in more detail, we understand that this is a smooth hammerhead shark. Unfortunately, they are not very common in our waters. They come here, especially in the summer, they are here. Today, we observe one outside, but we need warm waters and we need calm seas, because what we see from the boat is really, just, so what we see from the surface is really the dorsal fin, just the tip of the dorsal fin out. And these animals, like the harbor porpoise, they are super shy and they don't allow us to come very close with our boat usually. Okay, now you already see the next slide, and we're gonna move subject, and we're gonna talk about a little bit about photogrammetry. Okay, this is a research technique in which, through a very high quality picture, we can estimate the size of the animal. And knowing the exact size of the animal, it's quite interesting, because it gives us a good idea of the body condition and in what body condition this animal is. So by knowing the exact height of the drone and using some trigonometric calculations, it is possible to obtain this reading, this exact size of the animal. But currently, the sensors that we have in most of the commercial drones we use are not good enough. But luckily, there are already some teams like Ocean Alliance that have created small kits that we can attach to the drone in order to get this good reading of the height and be able to do the trigonometric calculations to know the size. And also this methodology is already used in the past, but we used to do it by planes or helicopters. And the fact that we can use a drone to do this and collect exactly the same data for the same purpose is great, because it's of course much less invasive for the animals, and is much cheaper to operate a drone that rents an helicopter or a small plane to do this. So today, thanks to the drones and to the to the level where the drones are now, researchers can collect this data using drones or setups that are around 1,200 euros. That is a very affordable price when we talk about marine research and tools for marine research. AIMM doesn't have any project or study with photogrammetry, but it's our intention to start collecting some opportunistic data, mainly on the big baleen whales that we have in our waters. But is from our knowledge that we have at least one scientific team in Açores that already work with this methodology with sperm whales there. Okay. And now we're going to move to another methodology, the collection of blows. And this methodology is already used for many years for cetacean research. Traditional, this technique was made with a long stick with kind of a platform on the end of the stick that we use to collect the exhalation of the animal or the blow. And we need to keep this platform on the top of the animal until he exhales, and so the boat needs to be close. And this technique was a little bit invasive for the animal, since we have to be there with a research boat really, really close to the animal in order to put our platform to collect the blow near the blowhole. And sometimes was not easy to perform. Sometimes the behavior of the animals doesn't really working well for this. Sometimes the sea was too rough to be able in the safe way to bring the boat close to the animal and to be able to perform this. So we did it for a long time like this, but I think was not a very easy methodology. But we did it because this is a very important research technique that have a very unique value, since the blow might contain very important biological information. And this information could be regarding DNA, could be regarding hormones or microbiomes that also going to be present in this blow. But luckily, today we have drones, and drones then can help us doing that. And is already possible, and we're going to talk now about this a little bit, to collect blows from whales and from a few species of dolphins with the use of these commercial drones. Okay. And comparing this to the classic way of collecting whale blows, the technique we saw before, this is much less invasive, is safer for the animal and for the researcher, it's cheaper, and it's easier to use on the field. So I will say that is really field friendly, and it's a great technique. And the best of all, it looks like the animal doesn't even realize that we are there to collect the blow, because, we're going to talk about this later, but most of the times they don't realize. Okay, now I'm going to show you a video. So okay, you see this is an impressive blow. This is from a blue whale, and was courtesy of Ocean Alliance that gave me this video. This is from a previous expedition they did, I believe, in Mexico. So Ocean Alliance started this project in 2015, collecting blows from whales that they call the Snotbot. So they have this project called Snotbot, and basically is this bot, there is the drone that collect the snots or the blows of the whales all over the world. They already collect from, I believe, 6 species, but we're going to also talk about this very soon. But they started this project a few years ago, and they have already a very good collection of blows collect, and also species that they manage to sample and to create the protocols for each species. And now we're going to see the same video, sorry, not the same video, the same moment, but record from other drone from a different perspective, and a little bit in slow motion. It's quite amazing. And I just want to highlight to you, probably you see that this drone, it moves, it kind of bangs a little bit with the blow of the whale. For you to understand how powerful, how strong these blows can be, this is a blue whale, and this blow, it can go maybe 7 meters, 8 meters high, depends on the wind conditions. And this drone, the weight of this drone is around 5 kilos. So, and he really bangs a little bit with the powerful of this blow. It's quite amazing. And we see from the previous footage that the drone got completely wet. They have a lot of sampling from this moment for sure. Okay, now we're going to talk a little bit more about the snotbot and the snotbot expedition that it happened already in Azores in 2021. So this year AIMM was invited to participate in this expedition with Ocean Alliance. The expedition took place in Fayal Island in Azores during 2 weeks of June and July. The main goal of this expedition was to collect blows from sperm whales, and this is why we end up in Azores. Azores is a great place to observe sperm whales. They have, we believe, resident or sperm whales that live all year round the islands. So we knew this will be a easy place to find sperm whales. It doesn't mean that will be an easy task to collect the blows. So this was the main goal, to collect the blows, but in parallel, we want to understand first if it's possible to collect a blow from this so unique cetacean that is a sperm whale, and then to create the correct protocols of blow collecting to be able to share with other teams in the world. So if they want to do this, they could learn from our experience here and have the protocols to do it. Well, this expedition, as I mentioned, it was in June and July, and it was a great success. And now we're going to explore a little bit what's happened there, and you will understand what I'm talking about. So here we have two different situations with the snotbot or with our drone in action. And you can see on the left, we have a blow from a baleen whale, a sail whale in this case, and where you can see that the blow is quite vertical and tall. I will say this is not so tall as the blue whale, but maybe can go 4-5 meters at height. And then on the right, we have a sperm whale that was the target of this expedition. And we also see the drone there. We see the animal here. The head is in this side. Okay, the tail is there. And you can see that the blow shape and even the direction is completely different. So unlike like the other baleen whales, which blow directly upwards, sperm whales blow forwards and a little bit to the left because they have the blowhole in the front left side of the head. Okay. And this is a very unique position for a blowhole in the cetacean. And that makes this a very special blow as well. And of course, this was our biggest challenge when we already know that, of course, before we get there, we know sperm whales blow like this. But when we get there, and in the first day, I remember very well, there was a windy day on the ocean, and the blows, they almost don't leave the surface. They were super low, I will say 1 meter high or 1.5 meters high. And this really challenged us to get the job done. Okay, so this was our platform, our boat, the vessel that we work. And how did this work? So we were there. In Azores, the whale watching industry, they have spotters, people that is inland spotting the whales and telling or guiding the boats to the area. So that kind of helping us a lot to drive the boats to a certain area. Of course, sometimes we were working outside the range of the spotters, and we need to spot the whales by our eyes. But the fact that they have so many whales there, it was not difficult to spot whales, it was difficult to collect blows. So, and basically when we are on the area, and now what we're gonna see is taking off from the boat. And well, you don't realize, but we are in maybe 1 meter swell that you can see the boat is rolling a little bit, and always the taking off and the landing moment of the drone was the most dangerous moment for us. So this is how it happened. So whenever we are in the area, we found a whale, we send the drone and we collect the blow. In theory, this looks very easy, and it is, but you need to have at least a very skilled pilot and an observer to make this with success. So now I'm going to show you this video that is a snot collection, okay? And this is from this is what the pilots see, okay? So the drone take off, we know the whale is somewhere here, and for this methodology to work well, we need a pilot and an observer. And the observer play a very important role here because he's the one guiding the pilot. The pilot is just looking at the screen, he doesn't know where the whale is, and the observer is telling, go straight, go a little bit more to the left, straight, 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 and I think you can already see there was a blow here. And the pilot, I think he didn't see yet, but probably now he managed to identify this animal, another blow. So the observer not just drive the pilot and the drone to the place, but also give informations to the pilot. What is the height of the drone related to the surface? Sometimes we were working in 1.5 meters, 2 meters, 3 meters swell, and we really need to make the drone come up in order to make the swell pass, or we could just get, well, catch by the swell. And you can see now the whale, the sperm whale just blow, and we can see on the camera that there are spots here. And this is a sign of success for us. So whenever we see spots on the camera, it means that we get the drone wet, and it means that we have a sample. And now, as soon as we get the sample, we swim backwards to the boat in order to don't lose the sample, because if we swim while with the drone frontwards, maybe the wind and the air will dry out or will make these drops fall from the drone and from our petri dish, and we don't want that. We want to keep them all as much as possible. Okay, I would like to play this video again. Let's see if I can, just to show you one detail. Let's wait until we get to the whale. You remember that I told you that in sperm whales, the blowhole have a very unique position. So try to see now when we get there, where is the blowhole in the head of the whale. And this makes it a challenge collecting samples from sperm whales relative to other species, because the pilot needs to work harder and fly at a very low altitudes in order to get it. Also, typically, we prefer to collect the sample as far away from the heads and the eyes of the whale as possible. So we would like to stay here in this position where the drone is now. But because of, in this time, the wind was coming from the back, so you see the blow is flowing, is flying to the front of the animal, we need to move the drone to this position. And I will say this eventually is the worst position to make impact on the animal, because we are right on the head, right in front of the animal. But well, in order to make this work, we had to bring our drone there, and we managed to collect this blow, for example, here without noting any kind of reaction from the animal. But yeah, but this depends. This blow collection depends a lot on the weather conditions. So the wind plays a very important role. Also, the species of the animals that we are sampling, and of course the pilot skills. It's also very important. Okay, so I already highlight this detail of the head. I think you understand. So now we're gonna move. Okay, so here we have two pictures with two different types of drones that we use in this expedition. On the left, we have the DJI Mavic 2 on the hands of Dr. Ian Kerr. Dr. Ian Kerr is the CEO of Ocean Alliance and is also the head, the brain behind this SnotBot project. This was his idea and was a great idea. But I just want to highlight you here. So these are commercial drones. You can buy them almost like this. What Ocean Alliance did is they build up these arms that you see here, and also this one on the top, in order to put our petri dish. For example, in this model here, they built these white arms here. in order to put the Petri dish on the front, and then here is just a Petri dish with a little bit of well, I forgot the name now, it doesn't matter, but it's kind of a tape that we can put it in and out easily. Also, well, these are two commercial drones. This is the Mavic, as I mentioned, and this is the Inspired. We managed to understand that we could collect blows for sperm whales with both, but for example, they are two different drones in, well, first on the budget. This one is around 1,500 euros, and this one is around 5,000 euros. Okay, so, well, it's a little bit of different budget, but this one, the Inspire, is bigger, so we can fly in harder weather conditions. And of course, I will say that this is the better for the job. But of course, if you are in the low budget, the Mavic also do the job. Also, a difference here is on the Inspire, we are able to put 3 Petri dish, okay? And on the Mavic, we just install 2. So the sample that we're gonna collect, of course, in the Inspire, we have more area, so it's probably to be bigger, the sample, that the one we collect on the Mavic, that we just have 2 Petri dish. I don't know if you can see, but all these Petri dish here are wet, are full of very small drops as well. This one here have a few drops, not so many as this one on the right, but this was already when the drone was flying back to the drone. In this case, it already landed in Dr. Ian's hands, and he collects, or he have our sample. Okay. Okay, another, so we talk already here about the challenges we have with the swell, with the fact that the sperm whales blow to the front left side, but there are also other things that challenging quite a lot. That was the behavior of the whales. And we understand that certain behaviors, it doesn't help. Imagine when the animals are socializing, they are swimming together, rolling, they don't really have a consistent movement or exhalation time. And this makes a little bit harder for us to predict where we should be with the whale in order to collect the blow. So we realize in this short experience there that the best behavior or option for us is when they are feeding, and we call this the feeding cycle. And what is this feeding cycle in sperm whales? So typically these animals spend around 80% of their time in feeding cycles. The sperm whales are deep divers, and they typically feed quite deep on the ocean. In the source, we have some very good studies on it that show us that female sperm whales, they tend to feed between 800 meters to 1,200. So it's quite deep. And of course, in order to get there, they need to dive for a big, long time. So usually they are underwater something between 40 minutes, 45 minutes up to an hour. And after this long dive, of course, they need to spend more or less 10 minutes at the surface. And this surface period is really important for them to breathe in and out in order to, well, to get more oxygen back on the tissues for the next dive. So this makes that the time they spend at the surface, they're going to be breathing exhalates quite often, let's say every 15-20 seconds for 10 minutes. So this is a great timing, a great chance for us to put our drone on the air, get there. And as you see in the previous video, we need 2-3 minutes. Well, that was an easy collect, I need to say. It was an easy catch. So this 10 minutes at the surface gives us a lot of time to collect more than one sample from the same animal if we want. So not just the weather conditions, not just the physiology of the animals, but also the behaviors is important to considering to succeed in this methodology. Okay, now more results. So besides this, all these factors that mess up with us and the ability for us to, well, get our work done, the weather condition was also very hard in Açores in these 2 weeks that we were there. For example, in 15 days or 16 days that we spent there, we were just able to work 6 days in the field. All the others were completely stormy, and we tried, but we just cancel and come back because it was too much. But we, well, at least in the first day, we managed to collect, I believe, 11 samples. The first day in the field that we were able to work. So right there, we prove that it's possible to collect sperm whale blows with drones. And this is a nice footage. This is the Mavic, so the smallest one. And this was a mother calf here. And you see the moment that the animal exhalates, the pilot kind of, let's observe this again. You see the animal will exhalate and the pilot will move the drone a little bit forwards in order to get the blow. And I think this was a good catch. When we are doing this, we also need to be aware of other animals around. For example, here we have a mother calf, and if you see after the adults breed, we have the calf that comes to the surface and also breeds. And we need to be careful with contamination, because we just want to collect samples from one animal in order to, well, to make our results and our study valid. So whenever you have many animals together, you need to choose one that is on the side and the wind doesn't bring the blows of the other animals to your area. And again, this is why the observer is so important, because the observer will be telling you what animal to go and what is the safest one to collect the sample. So this was our first day that was a success immediately. And then, well, in this time, at this point, we didn't know that the weather will really mess up the expedition, but we managed to collect a few samples. I'm going to show you later how many. Now, let me show you a few more footage from the boats. This one is a drone landing, or a drone is just landing, or another sample.
Yeah, good sample.
Okay, you can see that everyone was very excited when we understand that there is a sample there. The petri dish are wet. And now let's hear Dr. Ian Kerr during a small, I call a whale break that we have here.
So we're in one of those calm moments right now. It's pretty funny because it's almost like we have a fire drill. We're sitting here waiting, the equipment is ready, the drones are ready, but the whales are down. And suddenly a whale can surface from any direction and everybody jumps into their role. The drone dishes, the dishes are put on the drone, it's prepped, we get out there. The whales have been flying downwind today, which is actually harder for the pilot because the pilot has to fly backwards while looking at the whale. But we're getting it done, and it's exciting, but it's amazing. Someone will shout whale and then everybody is like gone to the wind to their different role.
Okay, and I think after this moment, someone screamed whale and we all jump and run to our positions. But you see, Dr. Ian Kerr, he was really highlighting that fact that the wind play an important role here. And I think the first image video that I show you about the drone collecting the blow was in this day. And well, besides the bad weather, this day, the weather here looks amazing and was amazing. And for you to have an idea, we spent almost 4 hours working because we just spot whales and whales and whales, and we want to get as much samples as possible. And this was like a 10 minutes break that we have when all the animals are down on the ocean, and there was no whales sighted around our boat, so we have a time like to rest, to eat, to go to the bathroom, to drink water, and get ready for another hour or 2 hours of work.
André, just let me tell you that we're already 8 minutes past the time. So because of the questions afterwards, we need to pick up the pace for a bit.
I'm almost sorry, I'm almost finished. Thank you, André. Thank you.
No worries.
Okay. More about our results. So we did in this expedition 100 flights. We spot 10 different species of cetaceans, although our target was just one, the sperm whales. And we managed to sample 3 new species with the snotbot technique. So we collect 61 samples from sperm whales. We collect 2 samples from sail whales and 1 from Brodus whale. And I just want to highlight here that all the petri dish in the drone in one moment make 1 sample. So from this picture here, you have 2 more petri dish or 1 more petri dish on the right. We consider this 1 sample, not 3 samples. Okay. So in the end, we had a lot of petri dish to clean and to prepare to go to send to the lab. Okay, now we also try to understand any potential impact that the drone could have on the animals while we are collecting the snot. And all of we did note some potential behavior response, but was in the very low number of animals. And all this response were followed by a very similar behavior that they were doing just before. And most of these reactions, they was all to the side and they were kind of looking up on the animals, but they don't really, they look to be like curious response rather than, for example, an alarming response. But please note that we haven't not analyzed yet all the footage from the drone, and we will have, well, stronger conclusions, I believe, soon. So what I'm telling you now is from the observations we did from the boat, not from the footage of the drone. Also, we note, and this was quite sad, a few interactions with cetaceans with plastic. Here on the left, we have a picture of the Riso dolphin that was coming to the surface with a piece of plastic around this dorsal fin. We didn't really understand if the animal was playing with the plastic or somehow the plastic just get entangled, wrap around this dorsal fin. But after 2 minutes, this plastic disappeared from his fin, so he was free of it. But here on the right, we have another situation. And also through the drone, we found 2 times, if I'm not wrong, yes, 2 times, sperm whales playing with plastic debris at the surface. And they were really they were playing, they were like touching with the head, sometimes biting it. It was quite scary to observe. And well, thanks to the drone, we were able to collect really interesting footage that will be released, and I think soon, but I didn't put it in this presentation. Okay, and now I want to just show you a very 2 examples, or 1 example of the potential of the drone for research. So this is a footage of a Brodus whale or a bride whale. This is one of the most rare species of cetaceans that we found in the Azores, and is also one species that is not very well studied, and is also a species that is very misconfused with another one in his identification, that is the sail whale. And we misconfuse these 2 species because the unique thing that is different is this detail here on the head. So the Brodus whale have 3 parallel longitudinal ridges in the head, and the sail whale just have 1. And I want to show you this picture. This was the best picture we took from our cameras on the boat of the whale. And now, very quickly, I want to show you the footage from the drone. So if it was hard to understand what I was talking about these longitudinal ridges, here on the drone foot, they are there. So you see, this is what I'm mentioning, these red arrows. And now if you look here to the right, the 3 ridges are clear, no question, this is a Brodus whale. And for example, now the same situation for a sail whale. You remember this first picture I showed you from the expedition, this was a sail whale. And in this picture, we can see, yeah, there is something here, but it's quite hard to understand. Now in the drone footage, it's quite clear there is just one big central ridge here. And if we move, for example, to a straight comparison between the species, yeah, we can see, okay, these are two different species, two different animals. And of course, these frames are from the drone. They have I didn't edit anything, so I just still frame from the video, but it's already quite clear that we can check and identify this species without mistake. Okay, and now to finalize, I would like to summarize a few advantages and disadvantages that we identify with the use of drones. So on the left side, the good things, you have a very low impact on the animals. For example, we don't need to have a platform or a research vessel close to the animals in order to collect the data. We just need to have our drone flying on the top of the animals, and we can collect the data from that. Nowadays, the data, the image we get from the drones are amazing. The quality, the cameras are really, really good. Also, and we already talked about it, the aerial perspective and the fact that we can see the group from the top, it really gives us another idea of the special distribution of the animals and how they move. The fact that we are taking our data out on the computer, watching a video, and we can stop the video, go back, go forwards, playing slowly, also will reduce the sampling bias. Okay, this is also quite important. We can observe the behaviors in detail, and again, not just the behaviors at the surface, but also the ones that are occurring a little bit underwater. Okay, and fly or operate a drone in the field is very cheap, and in most of the situations is not difficult. Okay, so again, they are field friendly. Now, the bad things about drones or using drones for marine research. As a new technology, they have some limitations. The biggest limitations that I feel so far is the flight time. Nowadays, the drone that I use, the Mavic 2, it flies almost half an hour, 28 minutes. So it's already 2 times more than my first flight, but nevertheless, we always want more. And because it's a new technology, it's also expensive. So the acquisition, buying a new drone is not cheap, although flying it and use it is quite cheap. Okay. It requires, of course, a pilot that it needs to be nowadays qualified and experienced. And believe me, the quality of data really depends on the skills of the pilot. And the last thing that I identify is you will collect a huge volume of data, and you really need to have big hard drives at home to store all this data, all this footage that you're going to collect. And keep in mind that this needs to be analyzed after. So, well, the job is not done. You have all this data, but now you need to analyze it. But in general, I think we can say drones can be excellent tools to study cetaceans in the ocean. And well, I'm sorry that I took too long. I really hope you enjoy these presentations, and I leave you with a nice footage from our last day in Açores. Thank you. Now it's time to answer your questions.
Thank you very much, André. I didn't interrupt you sooner because I think everyone was enjoying the videos very much. And the best part of these experiences, of these webinars, I think, is when people start sharing, you know, their personal experiences. And this was hard because the blow was going in this direction and the wind is going in this direction. These kinds of particular situations is what gives these webinars they make it more interesting. I myself was actually, I turned off the camera because I had a person here with me, a veterinarian. She was asking me about what kind of samples do you collect. Then the snot pot came along, and I realized it was the snot. This was extremely interesting. We have some questions. Some of them are from me, so maybe we should jump into them. Actually, the first question is mine. You were talking about the sun glare and how you need to put the drone in a certain angle. So by tilting the drone, does this not make the measuring of distances and the measuring of not only from the drone to the sea level, but also between the dolphins or whichever cetaceans you're measuring? Does it not make it harder for these measurements?
Yes, yes. That is a great question, Andre, and you are absolutely right. So this needs to be like a compromise. So I cannot tilt completely the camera to be like 45 degrees. Otherwise, the animals that I get in the center of the image will be, well, or on the side of the image will be disturbed. Special because my first drone and the ones I collect most of the sample from these behavioral studies, he have a GoPro. He doesn't have like his own cameras. So it was a really like strong fisheye effect. The video I show, it was already, I did a few additions to try to reduce this effect. But yeah, you are right. So whenever the dolphins, I mentioned that in the presentation, we try to choose one that is in the center of the image in order to try to reduce that problem. But yeah, this needs to be a compromise. So I cannot have the camera completely vertical, otherwise my image will be completely burned by the sun glare. And I need to found myself in the position. Usually I like to have the sun glare in front of me, but my camera is not getting it. But I know very well where it is, and I keep the animals in the dark area of the surface. But yeah, it's practice, and it's something that we cannot completely avoid, let's say.
Thank you. So the next one is from Foibush. I'm sure I'm not saying this correctly. So which is the best flight height to study the behavior of dolphins?
Yeah, well, it's Foibush is another very good question. I will say it really depends first on the size of your dolphins, okay? And then it depends what kind of behaviors you are looking for. For example, if you are trying to study mother calves and the nurturing behaviors from the calf with the mother, you might need to be lower than, for example, if you are just studying the general behavior of a group that we can assess from much higher. Okay, the group is traveling, or the group is socializing, or they are feeding. So it depends on the species and depends on the behavior. But I will say most of my flights for this work with the common dolphins, I did it between 20 to 25 meters, okay? And of course, in bigger groups, I might need to go a little bit higher in order to keep all the dolphins in frame. But I think at 20 meters with the cameras that we have today, we have already a lot of information. Even with the GoPro I was using, I was doing, I think, 4K or 3K, maybe it was just 3K. So then if I need, I can crop and zoom in the computer in order to get a little bit more detail if I want. And I kind of established the 20 meters as the lowest I can go in order to don't disturb the animals, since we were doing behavioral studies. And now I just found here a question from Alexandra asking if I found this whale again. I think you are referred to the minke whale, and actually I forgot to mention this in the presentation, because we found this same animal again 1 week after. He was doing a little bit better, but it was still swimming very, very slow. But I was quite surprised to see this animal again alive. In the first day we found them, my thoughts were not great about the future of this animal, and I think he didn't make it very well. But let's move on for another more maybe happy question.
We had a person, at least one person, joining from the other side of the world, from down under, from New Zealand. Came a bit late because of the hour difference, but it's always nice to have our friends from across the globe. So the next question would be, how do you protect the drone from saltwater? From Francisco Neves.
We don't really, for the snot collection, we don't really can protect the drone from saltwater. Because every time we collect a snot or a blow, we are getting the drone completely wet in saltwater. What we do is, whenever we get home, we clean the drone as much as possible. Well, I need to say these drones, although they, well, of course, they're full of electronics and metal parts, they are quite robust, and that inspire that I show. I think Dr. Ian Kerr mentioned to me that it was already the 5th expedition that this drone was doing, and he has something like more than 1,000 flights, if I'm not wrong. So although, and we know that saltwater and it's quite bad for well, electronics, these machines, they kind of hold it quite well. Now, from a different example, when we start doing our research here, and I was flying the drone, my drone was very high, far away from the blows, and I don't want to get close. But nevertheless, every time I get home, I clean with a wet fabric everything where I touch with my hand, because on the boat, most of the times, well, you can have your hands wet with salt water. Even if you dry, you can have salt in your hands, and then you touch the drone and you might pass some salt. And of course, I want to preserve and conserve my drone as much as possible. So every day after flying, I clean it with a wet towel, and I also make sure that the lens and the filters, they are clean. Plus all the sensors and everything on the drone, you need to make sure it's quite in good conditions, otherwise you might have an accident.
Now we have a very technical question from Karen Lucchini. So please, how do you define how many hours of flight you need to consider results significant or representative?
Sorry, André, can you mention again the question, because I could not hear you well.
How do you define how many hours of flight you need to consider results significant, representative? Significant or representative? So how much time do we need to actually collect information for this study to be valid?
Okay, but we are talking about the behavioral studies or this not, but well, I believe it should be the behavioral studies. Well, this was a time that we defined. So our aim in the beginning was to get 20 hours of footage from the drone to analyze. On the end, we to eliminate a few videos, like the example I showed, because it was just too many animals, and we ended up with 17 hours. Well, now we're gonna present our results, and we're gonna wait for the appreciation of the jury. And I hope they're considering this is significant, but it's not something that I know how to. Well, I cannot tell you really a number.
Another question from Jason Stafford. So what data are you collecting from Snotbot? Is it genetic? I think you mentioned genetic and hormones as well, right?
Yes. So we collect, we collect the sample, and then we send it to the lab. And we are expecting to get results in that, in DNA, in microbiomes, and in hormones. Although the hormones part is still quite new to be able to analyze hormones from blows, so we are still waiting for the results. Well, not we AIMM, but we are waiting for the results that Ocean Alliance might have in these samples to see if it's really possible to do hormones from Snotbot collections.
And last question, what is the process? So we have the Tichi thanking us for the presentation. And what is the process to clean the Petri dish between samples?
Yeah, that is it's a tough job that I didn't include it here because it was not really like drone related, but it's pretty much lab work. So every day is after the field work, we get home and we have all our Petri dish. First, they are sealed with kind of tape around, and on the boat, they go for a cool box, okay, to preserve it cool as possible. And then once at home, well, we were like in lab PPE, so with gloves, with masks, and we need to clean them, literally to scratch everything out to a small well, I'm sorry, but I don't know the name in English, but a small container, and then we label it, we put it inside a plastic bag, and we frozen to send to the lab. But yeah, the work, it doesn't finish right there on the boat when the drone lands. This part is quite important, of course, because we need to keep our samples clean as possible and don't compromise with the contamination, for example.
Oh, that's it for the questions. We have a lot of people thanking you for your time, André. I myself want to thank you for the time as well. Amazing footage.
It was a pleasure.
I'm sure it was a lot of trouble to go through all this footage and just show us the good parts.
Yeah, I have much more. I have much more that I could share, but we need 2 more days to be here. Yes. Sharing everything. 70 hours. No, I have more.
We really appreciate the time you put into this. It was obvious that you brought the good stuff for us, and it was really incredible to see these kinds of animals in this new light. I, for one, would have gone crazy with watching harbor porpoise toying around. It must have been quite an experience.
Yeah, it was.
Yeah. So from my part, that's it. Thank you very much. I would just like to point out for everyone that AIMM is an association, and they, as an association and not a for-profit organization, they are. I'm sure they're always looking for projects for funding, and they always need help from people. So do check out their websites and their social media. Follow them, or even help them if you can with a donation or by joining them as an associate. I don't know if André, if you want to tell us anything else that people can do to help AIMM. I don't know if you need volunteers or if there's anything else people can do.
No, we of course we are always looking for new partnerships, but individual members can also join us and help us in any way they can. We need always input from different areas. In AIMM, our core team, we are pretty much all marine biologists. So, we need people, we need lawyers, we need people from other fields to help us to run this NGO. But just if you follow us and keep checking our work and supporting us will be great. Thank you for that.
So yeah, that's it. So this video will be posted on YouTube afterwards. If you didn't manage to catch the beginning or some part, you can watch it later. Many thanks to AIMM and to André specifically for taking the time to prepare all this and to share it with us. And we hope to see you all in Sagres from the 1st to the 5th of October. You can register. You can still register at the birdwatchingsagres.com, and we'll see you there. Thank you, André.
Thank you. Have a good night, everyone.
Bye.